This example will show you how to evaluate simple piecewise functions. We're going to start with this one. F of x equals negative 2x minus 1 if x is less than or equal to 2, and negative x plus 4 if x is greater than 2. We are going to try to find the values of this function at different x values. I find that it is sometimes helpful to go ahead and put this on a number line. So we only have one breakpoint, which is at 2. We don't need any other numbers on this particular number line. This is the x number line. So when we have values that are less than 2, we're going to use this function right here, negative 2x minus 1. And when we have values that are greater than 2, we're going to use this function right here, negative x plus 4. So let's see how it works in the actual real scenario. So if we had to find f at 0, well, 0 happens to be right here in this interval. That means that we're going to use that purple function above that interval to plug in the 0 into. So negative 2 times 0 minus 1. Negative 2 times 0 is 0. So this is just negative 1. Now let's go ahead and calculate the value of the function at 3. X equals 3. That's the x value. So x equals 3 is right here in this interval. So that means that we are going to be using the red function up above that interval, which is negative. Then instead of x, we're going to plug in 3 and then plus 4. So this time it's a positive 1. Let's try this one more time. F at negative 1. Well, negative 1, just like 0, is in this interval right here. So that's negative 2 times negative 1 minus 1. Negative 2 times negative 1 is 2 minus 1. The value of this function is also 1. And one more. F at 2. So I deliberately used a different color here. 2 is a breakpoint for us. So how do we figure out which function to use? Well, if you have this happen, you have to look at the equal signs. So both of the piecewise functions have 2 as a breakpoint, but the second one does not have an equal sign. So that means that x can get really close to this 2. It can be 2.0001, but it cannot be actual 2. But the first function does have an equal sign next to the 2. So that means that x can equal 2 in that function. So that's the function we're going to use for the breakpoint. So negative 2 times 2 minus 1. Negative 2 times 2 is negative 4 minus 1 is negative 5. All right, let's try a different function. Let me go ahead and clear this one. Let's try this one. G of x equals 1/4 x minus 5 if x is not equal to negative 2, and then negative 3 if x does equal to negative 2. So really no number line needed on this one because we just have two scenarios. For all x's that are not negative 2, we're going to use the first function. For all x's that are negative 2, or just one x that is negative 2, the function will have a constant value of negative 3. So let me go ahead and show you how this is going to work. So if I had to say g at negative 4. So find the value g at negative 4. So we plug in negative 4 where we see x value in the first function, since negative 4 does not equal negative 2. So that's 1/4 times negative 4 minus 5. 1/4 times negative 4, that's negative 1 minus 5, negative 6. Well, let's try this again. G at 2. Well, 2 does not equal -2, so it's still the first function, 1/4 times 2 minus 5. 2 times 1/4, that's 1/2, minus 5, and that's -4.5. And then g at -2, since -2 equals -2, that is going to be your constant value of -3. All right, we'll do one more example with 3 functions instead of just 2. F of x equals 2x squared minus 1 if x is less than or equal to -1, then just 5 if x is in between -1 and 1, and x plus 3 if x is greater than or equal to 1. So 3 equations instead of just 1. I'm going to go ahead and do a number line to help with visualization of what's happening here. We have 2 breakpoints this time. We have -1 and 1. So for all the values less than or equal to -1, we're going to use 2x squared minus 1. For all the values that are in between -1 and 1, the function will have a constant value of 5. And for all the numbers that are greater than or equal to 1, we're going to use the function x plus 3. So let's go ahead and do some values. F at 4. So when x equals 4 in this interval right here, then we're going to plug it into the function above that interval. So instead of x, we're going to put in 4 plus 3. That is a 7. Now let's go ahead and do function value at -3. -3 is in this interval right here. So we're going to plug it into the x in that function. 2 times -3 squared minus 1. -3 squared is 9, so 2 times 9 minus 1. That's 18 minus 1, so just 17. And let's go ahead and do the function value at 0. Well, 0 is in between -1 and 1, so this is just a constant function value of 5. And let's figure out how to deal with the breakpoints. So let's say you had to do f at -1. So we're looking at the actual equal signs here. So the equal sign with a -1 is right here in the first function. That's the function we're going to use for -1. 2 times -1 squared minus 1. -1 squared is just 1, so that's 2 times 1 minus 1, which is just 2 minus 1, which is 1.